This is probably that 10,000 foot view out of the 50,000 foot we talked about the other day, so we're going to narrow it down a little bit. We're going to talk about network protocols. And don't forget, this test you should see available to you. And again, it has a due date of Sunday, but don't worry about that. That's just something I have to add in there to get it to take it. So we're going to talk about some rules of communication, the network protocols and standards. We're going to talk about data transfer in the network, in the summary, of course. These are concepts. These are not necessarily something that you would go home and talk about tonight as far as what you learned in networking that you're going to take with you forever. A lot of this stuff is going to seem like common sense. By no means is it intended to make you feel kind of degraded or whatever. The idea is to take a common concept and relate it to networking, so it will make more sense. So bear with me on some of this. So some of the things that you have to establish when you have to establish communication is you have to have rules. So with human communication, common sense, step out of your college student mentality and go back to like kindergarten. So some basic things have to happen when two devices, or two people in this case, try to communicate. So what ultimately has to happen is the person that's the source, somebody has to be the source, right? To communicate, you got to talk to somebody. Someone's got to start the conversation. And that person that starts the conversation is the source. That's not complicated, right? It's the same thing in networking. There's a source and a destination. Nothing changes there. What has to happen in order for the person to source a conversation, they have to have a topic. They have to be sharing something, right? Now, it may be not important to you, but they have to have some idea before they start communicating. After that, they have to think about how they're going to get it there. How are they going to get it there? They're going to talk verbally. Okay, they could do that. They could sign language it, right? They could use some kind of violence. She could walk over and smack him upside the back of the head. Yeah, that would get his attention, but it wouldn't necessarily share the message, would it? So in this conversation, we're going to assume that she decides to do it verbally. So she verbally communicates with who? The destination, right? It's got to be a destination person. That person is the receiver, obviously. He receives the signal, the message, through the transmission medium, and he gets he gets the message. Now, that's pretty simple. We do that all the time. There are lots of things here that we don't think about. Okay? So you walk up to somebody, or I don't know, let's say, for example, the instructor, myself, I walk in the classroom, I start presenting this lecture. Who am I in this picture? Source, right? It's a no-brainer. Who's the destination? You guys. Again, no-brainer. What's the transmission mediums I have available to me? Preferably verbal, right? I'm going to communicate this verbally. I could sign it, but there are two problems with that. One, I don't know sign language. And two, I'm gambling you do. Do you know sign language? I don't know. Do you know if your receiver or your destination knows it? No, you don't know that. So some kind of indication that, yes, I'm going to use that. I have to decide a few other things. I have to decide, you can hear me. I'm going to communicate. You have to decide on what language to talk. I'm speaking English. Is this a problem for any of you? I don't know that it is or not. Some of you, yes. What if I tried to speak Spanish to you? First off, I don't speak Spanish, so for those that do speak it would laugh, and those that don't know it would probably just play along like I knew what I was doing. Would you get the message? No. So we had to establish some rules. What about message length? How long can I talk before A, I run out of breath, or B, you get bored? We're going to find that out tonight, by the way. I'm just kidding. So there are some things that you have to think about before you even start talking. What about your texting? What if I decide to text all of you one time? I could do that, right? I could send you a text. I'd have to have your phone numbers, right? Do I have your phone numbers? I have phone numbers available to me in the system, but then I have to go get them. That's a problem. That could take some time. I have to text you in English or y'all's vernacular, 24BX3L or whatever that means. I don't know, texting language. I don't understand that stuff. So it would be in English. So there are things that have to go on to take place. Now, how do I know that you got the message? In a text message, how do I know? I don't, right? If you turned it on. What if we're talking here? How do I know you're getting the message now? Your eyes perk up and you come off your screen from checking your email or whatever. Okay, so we're getting communication. Lots of things are happening here that you probably don't think about. Well, the same thing happens in networks. You have a source, you have a destination, and you have to have some medium to communicate. That might be copper, might be fiber, might be wireless. I don't know. Whatever's established there. So it's the same things. Computers have to establish who they're talking to. They have to have a message. They have to know what protocol they're talking on. They have to have some guidelines on what if it's copper? What if these guys send a light signal down a copper wire? Is that a good idea? Not going to go very far, is it? No, that would be fiber. So they have to establish that. So it's the same concept. So one of the things you have to deal with is message formats. So this is pretty clear, right? Human communication between governed rules. It's very difficult to understand messages that are not correctly formatted, and it would take a while to figure this out for the most part. And what happens in this general area in the bottom? They change languages. I don't know what that says. Y'all might. I don't. So to understand it, you have to be able to encrypt it or decrypt it or figure out what it is and what language you're speaking. So there have to be rules for communication. There are probably a lot more rules than you think of because you've been doing it for a long time. So the same concept again. The idea is this person, the source, has this idea. She wants to convey it across the same concept and send it to the receiver. So he needs to see the same picture. Same things happen in networking. Pretty simple, right? I mean, we're not going over too far crazy into this. It's the same concept. If a computer wants to send a picture or a video image to another computer, imagine what has to happen there. This computer has to generate the picture. This guy has to go out. He has to decide what medium he's going to use, wireless, fiber, copper, whatever. He's going to have to decide what protocol to use. Does anybody know what protocol we use regularly on a daily basis on networking? TCP/IP, right? Okay. IP for short, by the way. So he's going to decide to use IP. He sends it down here. This guy gets it. He understands it's a picture. And he graphically presents it. What if that's not a picture? What if that's your bank webpage? Got your account information on there. You're just going to blast that across the network or the internet or wherever you check your bank account? No. So you have to encode it. You have to decrypt or encrypt it. You have to send it down here. And what has to happen on this side? He has to know what you're using. How are you decrypting it? What secret keys are you using? Have you guys gone to SSL websites, HTTPS websites? You haven't paid attention to that anymore? So you type in http.google.com. What does that tell you? You're going to go to Google, right? Do you know where Google is? Not what it is, but where it is. Do you know where Google is on the internet? I don't know. It has an address. It has it's got a place to go. Do we know what it is? How do you know google.com translates to what address? How do you know that? How do you know what IP address? How does your computer know? Your computer knows with a process called DNS, Domain Name System. DNS translates names to numbers. That's a protocol. That had to happen. It got an IP address in. What's an IP address? It's a network address. What happens at, that's layer 3. What happens up here in layer 5 and 6? This is an image. That has to happen. What happens at layer 7? Layer 7 is the application layer. The application layer has to know what application you're going to use to open it. Lots of things happen here really quick. And we're going to talk about all those things. So if you keep this, it's just very simple. Keep that in mind. It could help. Now, let's talk about mail. This is kind of an interesting way to present it. I've never seen these slides presented like this, but it's okay. We can work with it. So, let's talk about the information formatting if you want to talk to somebody or something else. Let's say that, and you'll hear this again, this alliteration again later on, different chapters. Let's say that you want to communicate with your grandma. She lives in another city somewhere. I don't know. Houston. Who knows? You want to send a letter to your grandma. Or you want to communicate with her. What forms of communication do you have available to you? Mail. You can call. You can text if she's on board with that, right? You can send a carrier pigeon. I don't know. You can send smoke signals if you want. Probably hope that grandma's got the same means on the other side to figure out what you're trying to do, right? Okay. But we're going to go with mail, obviously, because there's an envelope on the screen. Let's say that grandma is rich. Grandma's going to send you some money. Check. Big check. Big check. So how does she send it to you? You know you're going to get it, so you know what to do with it. How does she send it to you? Look at the mail system, okay? Working backwards, how does she send you that check? She puts in an envelope, okay? That envelope has to be addressed to you. How does she start that address?
Name.
No. Backwards.
Address, a zip code.
Keep going. What country do you live in? USA, right? Does she have to put that on there? Probably not, but used to, you had to, I guess, or if you're going to overseas. Okay, so it's going to the USA. If grandma wants to send you that check and you're dying to get it and she simply mails it to the USA, where's it going to go? Seriously, where's it going to go? Trash can, right? Post office is going to take that and go, I don't know what that is. I don't know where it came from. I don't know where it's going. We're going to trash it. Okay? What's the next piece of information grandma has to put on there to narrow down where you are? State. Okay? So she drops it in the mailbox, and let's put her somewhere else. Let's put her like San Diego or something. So she sends it to the U.S. U.S. Post Office gets it and says, this is going to Texas, to Dallas. Well, it's going to Texas. What do they do with it then? Trash it, right? Discard it, throw it away. Is that enough information? No. What does she have to further tell it?
Zip code?
No, yes, you don't really need a zip code, but okay, zip code's fine. That gets it in the... What does a zip code tell you? Zip code tells you what part of the state, right? So it's going to hit the U.S. Post Office. What's the U.S. Post Office going to do with it? Oh, send that to Texas. We're done with it. Once they see that it goes to the U.S., it's part of the USA, and they see the next place it goes, what do? Shoot it out. They want to deal with it? No. So Texas gets it. Texas Post Office says, all right, where does this go? Where does it go? Zip code, right? What does he do with it? Off to that post office, right? His hands are done. Okay? So we got a zip code. What else do we need? What address? Street. Boom. Zip code gets it, goes to the street, right? Hits the street. What happens when it gets to the street? What's the mailman do with it? He's going to drop in the box. Why? Still not enough information, is it?
That ain't that destination.
It got it to the street, but what house? Don't know, do you? So what's grandma got to do? Put the house number on it. This is all simple, right? You know where I'm going with this. So puts a house number on it. Postman gets it. He goes, good, got a house number. What does he do? He takes it to the house, drops it in the mailbox. What happens when it gets in the house? Opened by who?
Grandma.
No, grandma sent it.
Wherever she addressed it to.
Do you haven't addressed it to anybody yet? It just went to the house. Who opens it?
Anybody.
Anybody. What if Bob Jr. and Bob Sr. lived there? Got two Bobs, right? What if the check is to Bob Jr. because it's to cover his college tuition, and Bob Sr.'s a jerk? Bob Sr. opens it up, says, "Oh, look, it's a check to Bob." Boom. Off he goes to the bank, deposits it, tells grandma it didn't happen. He's a jerk. So what does she have to do? She continually refines who it goes to. Pretty easy, right? No big deal. Same thing happens to networks. Okay, so some things happen here. All right, first off, we have to have a message. What's the message? The check. What happens to the check? Drops in an envelope, gets encoded. What happens from there? You pick a medium. You're standing here with this check. What medium have you chosen? Mail. Which mail? Postal Service, FedEx. Depends on how bad Bob needs that check, right? Maybe she don't care. I don't know. So, just out of curiosity, because it's going to come up in a few minutes, when that letter gets dropped in the envelope, gets addressed to Bob, goes through all that process, gets to Bob, Bob opens it up, did anything change about that letter, that check? Nothing, right? So when that girl, the source, came up with that image and sent it to the destination, he got that image, right? Nothing changed right here. Nothing changed on that letter. So if we look at this and we break it down, what do we have to have? We had to have the destination where it's going, right? That's a no-brainer. We had to have the source listed. Everybody knows the return address, right? We had to start the letter. Grandma, she's old school. She does this formally. Starts the letter. You know where it starts. Did you start reading down here in the middle? I would if it was money. If it was a check, I'd go to the dollar side. I'm too lazy. Starts it with dear. Okay, fine. Where's it going to? Jane, in this case. There is data, and then who sent it? Okay. Were there any errors in this? No, there's nothing to indicate there. But it did end with a stamp. So it's pretty straightforward. If you look at it from a complicated view for mailing a letter. What happens when you compare it to a data network, to information on the network? Same concept, right? So I have an image that I'm going to try to send to you guys. Who am I? Source. Who are you? Destination. Who do I send it to? Now this is a small world, right? Our little network right here. We don't have, big world countries to go to. Okay. Where am I sending it? To this network, right? To y'all. How do I know where it goes? You have an address on your computer, right? Each one of your computers has its own host address. That's all you need. What network? What host? Okay. So, who's the destination? Oh, let's go over here. Now we can start down here. There has to be a hardware address. There has to be a destination and source. Okay? There has to be a destination and source for the computer itself. You have to know where it starts. You have to know where it ends, and then there's the data in between. Now that's pretty generic way to put it, and we're going to cover that a gajillion times, so don't panic. So, she has this communication. You should see the sunset. It's beautiful. The colors are amazing. How did she share that with him? Verbally, right? She chose that. Can he speak English? I don't know. Did he hear this in English and she spoke it in Spanish? I don't know. But you get the idea, right? So we can get off the human part of this and get into real stuff. Okay. Now, message size. What happens if the message is too long? What do you do when someone talks to you and they just keep going and going and going and going and going and going and they don't breathe? Is that annoying?
Yes.
What point do you realize the purpose of a breath? There are two purposes to breathing in a conversation. What's the first purpose? To live, right? Oxygen intake. What's the second purpose of a breath in conversation?
Give someone else a chance.
To interject your point, right? Stop talking. I have people in my life that I don't know how they do it. They don't breathe. They can talk for 30 minutes. They don't breathe. But there has to be a size. There has to be breaks in there. Same thing happens with computers. So each frame will also have its own addressing information. There's more here than what you think there is. Okay? Each frame, this word tells you volumes. You just haven't seen it yet. This frame will also have its own addressing information. And the receiving host and pieces are reconstructed, be processed for and interpreted. Now, I'm not going to go into detail on that frame piece yet, but we'll get there. The important thing to know is, just like sending a letter in the mail system, networks are the same way. Everybody has to know where you're going, where it's coming from, where it's going. Does it belong to them? There are some rules to engagement. Okay? Message timing. What time is the movie? Where are we meeting for dinner? Okay, fine. Pretty simple things. Kind of important. You guys came to class at 6, right? I came to class at 6. We arranged for that. The message was conveyed. We all made it on time. Everything's good. We know how it's going to go. Y'all know that I'm going to stand up here and talk your ears off for a while. And we also know there's going to be a stopping point. What do you think the stopping point's going to be? Definitely when the lecture's over, right? Hopefully a break in between if it goes long. Just for your edification, this part right here. If I go too long, throw something at me. I don't pay attention. But again, these are new PowerPoints, so we're still working it out. Now, delivery options. So, we have some ways to communicate. Think about this. You guys do it all the time. Okay? When you go and you talk to your friend, who are you talking to? Just that person, right? Okay. What if it's in a room full of people? Who are you talking to? Just that person, right? That communication is called a unicast in networking. Unicast, meaning one, right? So if I, as a computer, am talking to this computer right here, or this computer is talking to this computer only, it's a unicast. That's not very difficult, right? You'll hear this a million times, don't worry. There's a multicast. Actually, let's go the other way. This can handle broadcast. What if I want to share a message like I am now? Who am I talking to right now? Broadcast. Everybody, right? That's a broadcast. I'm sharing it with everyone. Kind of like TV stations, right? They broadcast out their TV shows and everybody gets it. Now what about multicast? Multicast is a select number of people. Say I just want to address the front row. So I specifically say, okay, front row, I want you guys to stand up and do 20 jumping jacks. What are they going to say? Oh, crap. You guys joking, right? Okay. What are y'all going to do with that information? Ignore it, right? Why are you going to ignore it?
Because it wasn't addressed to you.
It wasn't addressed to you. Exactly. How do you know it wasn't addressed to you? Because I specifically said the front row. When I said the front row, what did y'all do? Tune me out, right? Okay.
So which one is that, multicast? Or?
That's multicast. Now, what's an example of multicasting? How many of you have DirecTV? Well, it's not direct. Well, Uverse. A couple of you, right? Do you have any idea? Okay, let's go back for a second. Back in old school days, when you had a two antenna that you had to turn the knobs, how did you tune in the channels?
Turn the knob and move the antenna.
You turn the knob, right? And it tuned the TV to a specific frequency. And on that frequency, channel 5 was broadcasting, right? Did it go to everybody? It went to everybody, right? But who was listening to channel 5?
Whoever was on channel.
Exactly. Whoever had their TV tuned to channel 5. What about everybody else? Were they listening to channel 5? No, they're ignoring it. Uverse is the same exact way. Let's say that I'm tuned to channel 501. HBO, right? And 5 or 6 of you are too. But several of you are tuned to channel 5. We're not watching the same information, right? But they're coming along the same wire. How do you do that? It's multicast. Why is it multicast and not broadcast?
You're signaling it.
It's more than one, but not everybody. Can I hear Channel 5 information coming on my network link? Yes. Am I listening for Channel 5? No. I'm only going to grab the packets that have 501 in them, the movie I'm watching. So this is a select few, if you will. Broadcast is everybody. Unicast is one-to-one. Now, don't get caught up in this. We're going to hear this many, many, many more times. There is significance to each of these pieces of information, all three of these. So don't panic on that. You're going to hear that quite a bit, these three. Yes, we are going to get bigger and bigger. But what I want you to do when we do that is maintain the simplicity that we've been discussing. It's very simple. Just keep hold of that simple picture. So look at computers. If we have a unicast, who am I talking to? Just one, right? Same thing with the person. Same thing in computers. What about multicast? Am I talking to one or am I talking to everybody? Neither, right? Just certain select ones that are listening. And with broadcasting, I send it out, it hits the switch here, it goes to everybody. What am I doing? Talking to everybody. It's the same thing as talking to, you do it every day. You've done it all day long. You've unicasted, you've multicasted, and you've probably broadcasted. I'm sorry?
People that like Snapchat, you can send it out to you one, and you send it to everybody.
Have you ever seen someone send a Snapchat to every single person that's on Snapchat? That'd probably be bad, right?
Well, you have
That would be a
to-
broadcast, right?
You're on your friends list, yeah.
Then what would that be considered?
That'd be multi.
Multicast. You're only sending it to certain few people that you intend to send.
Yeah.
Do other people want to see your Snapchat stuff? Probably not. It depends. I don't know. Maybe, maybe not. So that's a lot of multicasting going on right there. Unicast, not so much because, well, it's social media, so you can get over it.